Hello, in this video I'll do the section um, 12.5, the problem solving with normal distribution. This whole section based on the table that's called z-score and percentile table. You have a two column, you see z-score column and percentile column. Okay, z-score z-score percentile. I should say percentile is a percentage. You guys see here the number, let's say under percentile 86.43, which is same as 86.43%. Okay, again, this whole section is based on the table, and table is always provided. Okay, use the accompanying table of z-score and percentile to find the percentage of the data item in the normal distribution below and above the z-score of 1.3. You got to find the percentage. Watch here, percentage of data item below that z-score 1.3, and part B, you got to find the percentage of data item that lies above the z-score 1.3. Okay, 1.3 is a crucial number here, which is z-score. Let's find 1.3 on the table. 1.3 you can see here. And what's the percentile for 1.3? 90.32. Okay, and that means this 90.32 is percentage below that z-score, which is 1.3. Therefore, whatever you percentile here is below that z-score. Okay, therefore you can answer this question by saying the percentage of data item that lies below that is z-score is 90.32, and the percentage of data item that lies above that z-score is 100 minus 90.32. If you subtract, you get the percentage above that z-score is 9.68. 9.68. Okay, that's all you do. Alright, remember that for below, this all percentile here is percentage below that given z-score. Above is you subtract from 100 to get the percentile or percentage of data item that is above that given z-score. Okay, question number 2. Use the table here to find the percentage of the data item in the normal distribution that lies between 1.4 and 2.6. Okay, between 1.4 and 2.6. Okay, you have to look for z-score 1.4 and the percentile for 1.4, which is going to be 91.92. Okay, it's 91.92%. And for 2.6, the percentile going to be, let's see, 2.6, 99.59. I'm sorry, 99.53. 99.53%. Now to find the data item percentage between 1.4 and 2.6, z-score going to be 99.53 minus 91.92. If you subtract, you get 7.61%. Therefore, the percentage of data item that lies between these two z-score is going to be 7.61. Question number 3. The systolic blood pressure reading for the population of adults are normally distributed with the mean and the standard deviation of 16. Okay, remember that 125 is the mean, standard deviation is 16. Reading above 140 is considered to be high blood pressure. Begin by converting the given blood pressure to the z-score, then use the accompanying table of z-score and percentile to find the percentage of people with the blood pressure reading below 149. Therefore, this 149 is data. First, you got to convert 149 to the z-score. Okay, for data, here is 149. Okay, now z-score of 149. Remember that we have the formula: z-score of data equals to data minus mean divided by standard deviation. And to find the z-score for data, you use the formula 149 minus 125, that's the mean, divided by standard deviation, which is 16. Okay, and 149 minus 125, which is which is 24 over 16, let's get 1.5. Therefore z-score of z-score of 149 is 1.5. Now I'm looking for percentage of data item below that z-score 1.5. In other words, we're looking for percentage of people whose blood pressure reading is below 149, which is same as 1.5 as a z-score. Therefore I'm looking for 1.5 here, 1.5 here, and reading percentile for 1.5, which is 93.32 or 93.32%. In other words, 93.32% people has a blood pressure reading below 149. Okay, in other words, 93.32% has a blood pressure 149 below. Okay, question number 4, and this is similar to the other question, but you got to find the percentage of people with reading in between 152 and 161. Therefore the idea here is you got to convert 152, convert data 152 to z-score, z-score, I should say like this, convert 152 to z-score, convert 161 to z-score. Okay, then you find the percentage between these two reading using the table. Okay, what's the z-score of 152? What's the formula? We did before, 152 minus mean is 125 divided by 15. Okay, let's do the math here. Okay, 152 minus 125, 36, I'm sorry, this is 27 divided by 15, which gives you 1.8. And similarly, z-score of 161 going to be 161, the data, minus 125, which is the mean. Again, see, 125 is the mean. Standard deviation is 15, and if you subtract 161 and 125, you get 36 divided by 15, which gives you 2.4. Therefore you have a z-score, 2 z-score, 1 for 161, 1 for 152. Let's find the percentage for each z-score. Okay, for 2.4, 1.8 z-score, 2.4 z-score. What's the percentile for 1.8? Let's do that. 1.8 is 96.41, 96.41 percentage. For 2.4, z-score going to be 99.18. Okay, 99.18 percentage. And if you subtract this two number, 99.18 percentage minus 96.41 percentage, and the difference here is going to be, let's do the subtraction here, going to be 2.77. Okay, therefore, and the percentage of people with reading between 152 and 161 is 2.77. That's what you do. Question number 5. The weight of 12-month male are normally distributed with the mean 26.6 pound and the standard deviation of 2.6 pound. Use the given table to find the percentage of 12-month-old male whose weight more than 26.5 pound. Here the data here is 26.5 pounds lbs per pound. I'm looking for how many percentage of the 12-month-old male whose weight is more than 26.5 pounds. To do that, first you need to convert 26.5 pound to z-score. Okay, convert 26.5 to z-score. Again, we did that before. We have the formula here. Okay, the data, z-score for the data can be data minus mean divided by standard deviation. I'm going to use that. Z-score of data is 26.5 equal 26.5 minus mean is 22.6 divided by standard deviation, which is 2.6. And if you subtract, you get on the top 3.9 divided by 2.6. This gives you 1.5. Therefore, looking for z-score 1.25. 1.5 is here, and therefore you see that 93.32% are below 1.5. Remember that this is the percentile is percentage below that value, 1.5. Okay, remember that 1.5 is same as 26.5 pound as a score. Okay, remember that 1.5 is z-score for 26.5 pound. Therefore, but I'm looking for more than, that means you subtract less from 100%, you get the percentage above 26.5 pounds. Okay, well, how much you get? 900 minus 93.32 gives you 6.68%. Therefore, 6.68% of percentage of 12-month-old male weight more than 26.5 pound. Okay. All right. Question number 6. Okay, the table to the right shows the selected age of licensed driver in one country and corresponding percentile. Find the percentage of driver who are younger than 75. Therefore, the percentile of 75 age is 98. Okay, in other words, 98% of the people are younger than 75. That's what the percentile means. Therefore, the percentage of driver who are younger than 75 is 98%. Remember this percentile here. The age is 75, 98 is percentile. In other words, 98% is younger than 75. In other words, 87% is younger than 65. In other words, you can say 4% is younger than 20 years old. That's what it means. Okay. Question number 7. The table to the right shows the selected age of licensed driver for one country and the corresponding percentile. Find the percentage of driver who are at least 25. That means at least 25 and younger than 75. Okay, at least 25 and younger than 75. What's the percentage of younger than 75? 99% are younger than 75. Okay, and how much percentage? That's I'm looking for this. And 25 here. 13% are what? 13% are less than percentage less than 25 years old. 25 years old, right? Okay, again, 99% are younger than 75 years old. 13% are less than 25 years old, correct? If you subtract 99 minus 13 percentage, you get 86%. Sorry, 86%. These are what? These people are older than 25 and younger than 75. Okay, these percentages are older than 25 and younger than 75. In other words, this 86% people are at least 25 years old and younger than 75. This 86% are older than 25 because they're at least 25 years old but younger than 75. Okay, that's the answer here. The percentage of driver who are at least 25 years and younger than 75 is 86%. Question number 8. A female insists that she will never marry a male assert as or shorter than C, knowingly that only one male in 5,000 falls in this category. Okay, assuming mean height of 68 inches for male and the standard deviation of 2.5 inches, approximately how tall is this female? But okay, you're looking for how tall, like a data value, not the percentage here, data value. And notice that the formula for data gonna be a mean plus z-score times standard deviation. That's the formula. And what we need here is we need the mean. Of course we have a mean 68 inches and we have a standard deviation. We have a 2.5 standard deviation. What you need here is z-score. And notice that 1 out of 5,000 is going to be 0.0002. Okay, that's the percent. And as a percentage, if you change that percentage, it's going to be 0.02% as a percentile. Okay, percentile 0.02. In other words, percentage of male shorter than this female is 0.02%. There's few, of course rare. Now look for this percentile and find the z-score from the table. Closest value or exactly the same one, 0.02 percentile. Look at the 0.02 percentile is here. Now what's the z-score for 0.02? Okay, 0.02 percentile has a z-score negative 3.5. Okay, remember that this is the percentile. 0.02% is percentile and that has z-score negative 3.5. Now use that z-score on the formula and find the data, which is the female, the height, and round to the nearest whole number as needed. Therefore what I'm going to do is data equals to mean, which is 68 plus z-score is negative 3.5 times standard deviation 2.5. okay, 2.5. And if you simplify, this value going to be 59.25 inches. But if you round it to whole number, that's the instructions, you round it to the nearest whole number, which is going to be 59 inches. Therefore the female height here is 59 inches tall. Okay, that's all about this homework on the lecture for this section 12.5. Thank you.